Hello, how are you? Welcome. Hope you're having a good day. If not, hopefully that'll change once we do some good chemistry. Our objectives for this video are the following. The first is, I'd like for you to be able to draw the periodic table for the first 20 elements from memory. That's that stuff. Some of you can already do it, some of you cannot. This video is for the latter group. Secondly, I'd like for you to be able to quickly recall the orbital diagrams. That's the electrons in boxes. This thing, which we've already covered. Okay, for the first 20 elements. Again, the key word here is quickly. So this is revision. I'd like for you to be able to do this for all elements up to calcium. Secondly, thirdly rather, I'd like for you to be able to quickly recall the main level configurations. That's this stuff, 2882, 2881, and so on, for these first 20 elements, again from memory. Numbers 3 and 1, or 1 and 3, are not formally on the IB syllabus. So of course you don't need to memorize the first 20 elements according to the IB, because why? They give you the periodic table. And they don't really cover this stuff, the 281, 282 stuff that I'm going to show you. But I think both of them are actually quite important. And especially, well, both of them really will save you some thinking time on the exam. So let's get started with this first one. We begin. First of all, here's our the first, how many elements is this? 86 elements of the periodic table. Most chemistry does not concern itself with many of these elements here. When was the last time you heard of, I don't know, rubidium or, I don't know, selenium? They don't get used either in the lab, or most of life doesn't use them. So we don't care too much about them. We can cut them off and just stick with the first 20 elements up to calcium. And then we can squeeze that together and we end up with the first 20 elements of the periodic table, which is most of what you do in chemistry at this level. Okay? This first 20 element periodic table is very useful. I recommend all chemistry students memorize it because it will save you time on the exam and it'll make you a better chemist. So I'm going to give you now a way to do that memorization. It's just a silly mnemonic that I came up with. Some students like it, some students find it very silly. I think it's quite silly, but I like it anyways. We have 3 characters in this mnemonic. One is Lee. Lee happens to be Asian. We have this girl. She's British. We don't care about her name. All we care about is the fact that she's British and she has a British accent. And we have that kid there who's Namgal and he's drinking a slushy. He's maybe from Indonesia because Namgal sounds like an Indonesian name. They're in the high school cafeteria, as you can see. That's the setting for this story. Here's what happens. Lee's laughing, okay? Why is he laughing? We'll see why he's laughing in a second. But here's his girlfriend, the British one, and she says, Lee, babe, see, it's not funny, it's not funny. Okay, she sounds very British in that way. What does she not think is funny? The fact that her friend Namgal, which I'll show you in a second, Namgal is sipping what? Chlorine and argon. Jesus. Chlorine is very toxic. Argon, for you to get it into a slushy form, it must be extremely cold. So what can we imagine is going to happen to Namgal? He's probably going to die. He's going to choke and die. How does this help us? What is this ridiculousness? Okay, these are basically the first 20 elements of the periodic table. Let's go through it again, but we changed the words a tiny bit. So we have Lee, and Lee's laughing. Hydrogen, helium. Then his girlfriend says, Lee, babe, lithium, beryllium, boron. C, carbon, no funny. Nitrogen, oxygen, fluorine, neon. We're done with period 2. We move on to period 3. Namgal sips chlorine plus argon. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and, of course, argon. And then that guy there is choking. Why is he choking? Well, because of the slushy. What does he say as he's choking? He says, ka, which is what? Potassium and then calcium. So there we have it. We have the first 20 elements of the periodic table. If you go through this story just a few times in your head, maybe try writing it down. You should have it down. It's really quite simple. And we're done. We have that now. The idea now is that you can answer some rapid questions without having to look at your periodic table. So let's try this. Sodium is in what period? Try and think. Pause the video if you're not too sure. Okay? You think, that's the first period, right? Then Li blah 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 blah. That's the second period. Then Namgal, sodium, period 3. Okay, here we have first period, second period, third period for sodium. Nice and good, beautiful. Next question. Magnesium is in what group? We just said Namgal, sodium, and then what? Magnesium, right? So that must be what? Group 2. Sodium, magnesium, group 2. Again, pause these immediately you see the question so you can try it on your own. So of course there is in group 2. Next one. Is chlorine above or below fluorine on the periodic table? Pause the video. Try it. Is chlorine above or below fluorine? We say Li babe si no fune. That's fluorine. Namgal sips chlorine plus argon. Therefore, chlorine must be what? Below, okay? So here we have chlorine, and we have fluorine on top, okay? So our answer there is below. Last question. What are the first 3 noble gases? Pause again. Try this one on your own. We have what? We have hydrogen, helium. Lee is laughing, right? Then what do we have next? We have Li bebsinofene. That is what? Neon. Then Namgal sips chlorine plus argon. So we have what? Helium, neon, and argon. Helium, neon, and argon. The one in period 4 is, I think, krypton, but you don't have to know that. Okay? So you see what I mean? If you have these in your head, just these 4 sentences, then you can generate answers to questions fairly quickly without having to go flip to your periodic table. Once you become a real chemist, I think you should have the entire periodic table in your head, but that is an issue for another day. So now I say we're done with this first one. And obviously you might need more practice before you really check it off. Let's go to the second one, these electrons in boxes. This is revision. We had learned in a previous video that electrons are what? They're contained in orbitals. An orbital is a region of space where we have a high probability of finding an electron. And we represent these orbitals as just squares or here rectangles. So this is an orbital, this is an orbital. The orbitals are grouped into what? Sublevels. What's a sublevel here? A sublevel is basically just a color group. So you can see some sublevels have just one orbital, the s. Some sublevels have 3, some have 5, some have 7, and so on. Then the sublevels are further grouped into main levels. So we have here the n1 main level, the n equals 2 main level, n equals 3, and so on. Okay, well that's all covered, right? We also said that even though we're drawing these boxes, what we're really representing are these 3D shapes. And we learned the shapes of the S and the P. Let's go through it for oxygen so we can remember. So we have one S with one electron bobbing around in that spherical shape. Okay, we can add a second electron. Then we go to 2S, which is larger but also spherically shaped. We can add a second electron there. We have the 2P after that, which is what? Dumbbell shaped. We have the X in the X orientation, the Y in the Y orientation, and the Z going in and out of the board, but we draw it diagonally because we live on a 2D board. And then we can add that second electron to the 2P, and it's bobbing around there in that orbital. We also learned how to fill in the first, I think, 36 elements, the electronic configurations. We said first you fill in the 1s. We said helium really belongs here. Then the 2s1, 2s2, and then 2p1, and so on. Then the 3s, the 3p. So basically you're filling in the period and paying attention to the blocks. Okay, we get here to 4s, and then we have a little trick. We need to fall down the stairs from 4s to 3d, and you can extract that from looking at your Madelung diagram. Hopefully you remember that. After the 3d, we rise up to the 4p. Again, we don't care too much about many of these atoms, so let's get rid of them and squish it. And that way, we can what? We can show all the electronic configurations for the first 20 elements on one diagram, which is quite helpful to see. So let's go through it. First here, we fill in what? 1s1, then 1s2 over there. Then here, the 1s2 is filled throughout. So we're only filling in the 2 level. Why? Because we're in period 2. So 2s1, 2s2. Then we move to the P block, 2s2, 2p1, 2s2, 2p2, p3, p4, p5, and so on. Here we filled in the first 2. We're filling in the third one. We fill in the S, and we start to fill in the P's, 1, 2, 3, 4, 5, 6, and we're done there. And then here again, we replicate the same thing. Again, I want you to study this picture. Make sure you try to copy it down. You should be able to generate something that looks like this somewhere in the synapses of your cerebrum. Let's try some rapid fire questions. What is the valence shell configuration for sodium? Pause the video, see if you can think about it. What period is sodium? It's in the what? The third period, right? Namga. Therefore, it must be what? 3. And it's the first element, so it must be in the S block. So 3s1, right? Here we have sodium, third period. Therefore, we're filling in the 3. This is the valence shell, 3s1. Let's try the next one. What is the full configuration for boron? Again, think back to Lee and his girlfriend. We have Lee babe. The B there stands for boron, and therefore we're just in period 2. So we have 1s2, first one, then 2s1, 2s2, 2s1, 2p1 there for boron. So the full configuration is 1s2, 2s2, 2p1. Okay, next one. Which of these has a valence configuration of 3s2, 3p5? Again, pause the video. See if you can think through it. 3s2, 3p5. What's happening there? Well, we're almost full. 3s2, 3p6 would be full, right? So it must be just right before the full group. What's right before the full group? The halogens, either fluorine or chlorine. Which one of these is in period 3, fluorine or chlorine? If you think about the mnemonic, you would know it should be what? Chlorine. So let's look at chlorine there. There's chlorine. So we can see the valence configuration is 3s2, 3p5. Another one. Which of these has a valence configuration of 3s2, 3p6? Oh, it's so easy. We just added one electron here. And we know that Namga was sipping what? Chlorine plus argon. All right? Chlorine there plus argon. Beautiful. Beautiful. Okay, now I'd say we're maybe halfway done with this one. You probably have to do a bit more practice. There'll be practice on this on the website. Let's move to the last one, these main level configurations. It's really quite simple. Here's the problem. This full configurations where you show the orbitals and the sublevels is a bit complicated. And secondly, the difference between sublevels is often not too important. So the difference between 2s and 2p and 3s and 3p, for example. So here, the difference in energy between these two electrons in borons 2s and borons 2p and the single electron in the 2p, often we can ignore it. And so what we can do then is let's take calcium, we can just focus on the main energy levels. So instead of thinking about the S's and the P's, we just count the electrons in the whole main energy level. Here we have 2, here we have 2 plus 6, so 8, then 2. And we can represent that on an orbit diagram. So the orbit was how we used to think electrons moved around the nuclei. But we changed that to this orbital. But sometimes we still draw it this way, not because we're stupid, but because it's easy. So we do the 2 there for the first main energy level, then the 8 for the second, the 8 again for the third, and then the 2 there. And that's one way of drawing the main or the principal main energy configurations of calcium. We might also call it the main shells. Shells energy levels are synonyms. Okay, so 2882. I want you to be fluent with these two ways of representing electronic configurations. Okay, the simple main shell one and the full one with the sublevels and the orbitals. So what are we going to do now? We're going to take the first 20 elements and we're going to show the main energy configurations of these first 20. So first we put down just the shells. We have 1 shell, 2 shells, 3 shells, and 4 shells. Or if you like, 1 main level, 2 main levels, 3 main levels, 4 main levels. Then we add the electrons. Here we have 1 electron, 2 electrons. Now that shell is full. We go here to 2, 1, 2, 2, 2, 3, 2, 4, and so on down to 2, 8, where we fill it up. We come here to 2, 8, 1, 2, 8, 2, and so on down to there. Argon 2, 8, 8, we filled it up. And we start with 2, 8, 8, 1 and 2, 8, 8, 2. This is a picture I want you to study. Maybe write it down. Definitely you should have it somewhere in the back of your mind. So let's try some rapid fire questions. This is the last set of rapid fire questions. So if you're feeling tired, don't feel tired. Pause the video and try to think about this one. Which of these is the principal energy level configuration for sodium? Again, pause, think about the mnemonic, think about that picture. Okay, sodium is Namgal, right? That's the third period. If you remember our mnemonic, if it's the third period, it must have 3 shells. So we can cross out that one. It's definitely not that one. It must be one of these ones. Sodium is the first element in the periodic table. So it must be indeed, why is my pen not working? It must be indeed 281. Okay, there we are. Sodium, 281. Beautiful. Next one. Which of these is the principal energy level configuration for boron? Boron, Lee, babe. That's the second period, right? So it must have how many main levels? 2. So we can cross out this one. Definitely not that one. And is it the first element in that period? No, it's not. It's the third, right? So it must be 2, 3. Boron there, 2, 3. Let's try another one. Which of these has a principal energy level configuration of 287? Pause the video again. Think about it. 287. What could this be? It's in the third period, right? So it's definitely not oxygen. And it's probably not fluorine either. Only chlorine is in the third period. The fact that it has 3 main levels here tells us that it's in the third period. The fact that it has 7 tells us it must be one of the halogens, right? So obviously it's going to be chlorine there. So we have 287 for chlorine. Last but not least, which of these has a principal energy level configuration of 2,8? Pause the video. Think about it. 2H, that means it must be a noble gas, right? So probably it's argon or helium. Is it helium? No, helium is the first one, so that would just be 2. Is it argon? No, argon is in period 3, so that would be 288. So it must be none, right? Or neon. The answer is none here, but what it really is neon over there, okay? Neon and none are those, what's the word for things that can be spelled? If you move the E, it becomes neon. What's the word for that? Okay, anyways, the answer there is none, or if you like, neon. I believe now that we're partly done with this objective. What's left for you to do? What's left for you to do is to practice. But I will leave you to do that practice on your own. And in the meantime, I will bid you farewell. Bye-bye.